Okay, today we are working on using methods of solving systems of linear equations on word problems, actual problems from life that we might encounter. So I'm going to go through number 1 for you here, and you want to find the value of two numbers if their sum is 12 and the difference is 4. So the two numbers I'm going to call them x and y, just like usual. Now, what I know is that their sum is 12, so I'm going to write that as an expression. X plus y equals 12. And their difference is 4. So I'm going to write that also. X minus y difference equals 4. Now what I have is a system of equations. I see that this is really 1x plus 1y equals 12. 1x minus 1y equals 4. If I add the expressions going straight down, x plus x is 2x. Positive y minus y cancels out. You don't have that anymore. Bring the equal sign down. And then 12 plus 4, 16. 2x equals 16. If you solve for x, you get 8. Now we plug that back into one of our first equations. Let's plug it into our first one here. X plus y equals 12. Well, if x is 8, then it's 8 plus y equals 12. Solve for y, and you get 4. So our answers are 8 and 4. Very similar on number 2. Now, number 3, bear with me because this is a tough one to understand. Before I explain this, I'm going to just write down in this space up here what we're talking about. Now, if I take a boat downstream, that's my little canoe. There is me sitting in the canoe, and I'm going downstream, and I say that the boat has a rate of, let's say, 10 miles per hour. I'm paddling hard, and the stream has a rate of 5 miles per hour, or the current is 5 miles per hour. How fast am I actually going compared to someone who is standing on land? Well, you add them if I'm going with the current. So altogether, I would be going 15 miles per hour, even though I'm only paddling at 10 miles per hour rates. Now, let's say that I am going the opposite way. The stream is still going 5 miles per hour, but I'm trying to come back up the stream. So now I'm sitting here, I'm looking this way, and I'm still paddling at the same rate, 10 miles per hour. But I'm trying to go against the stream. What happens is that you have to subtract the current from your actual rate. So truthfully, I would only be going 5 miles per hour, even though I'm doing the work of someone who would be traveling at 10 miles per hour. That's what this problem is talking about. Now, if I took a boat 210 miles down and back on the Mississippi River, the trip downstream with the current would take me 10 hours. So I'm going to say what we know is that the rate times the time equals the distance. So going downstream, that's going to be 210 miles downstream. And the time they told us was 10 hours. And the rate, we don't know. But what I do know is that the rate is not actually my rate. The rate is a composite, just like up here, where my boat, I'm going to say boat and current together equals 15. Boat was 10, current was 5, had to add them together. But over here going back upstream, I had to take the boat, how fast I was going in the boat, and subtract the current, and that's how I got the 5, right? So the actual rate that I'd be going in my boat downstream is a composite of the boat speed plus the current speed. So boat speed plus current speed is my actual rate. I multiply that by 10 because that's my time, and that would be 210 miles downstream. Now, the trip back upstream against the current took 70 hours. So I know rate times time equals distance. Distance is the same. I still have to take 210 miles back upstream. My time is now 70. And I know that my rate is not really my rate. It is a composite of B minus C. How fast the boat's going, subtract the current. What I can do is simplify these equations right away. This set right here, B plus C, is being multiplied by 10. To undo that and get B plus C by itself, I'm going to divide by 10 on both sides of the equation. So I get B plus C by itself, and that equals 21. Over here, I'm going to do the same thing. I'm going to get B minus C by itself by dividing by 70. And then I can see that B minus C equals 3. Look at that. I can solve a system of linear equations now. I bring this over underneath here. B plus C equals 21. B minus C equals 3. Solve this system. The C's will cancel. B plus B is 2B. C minus C is no C's at all. And then 21 plus 3 is 24. Solve for B by dividing by 2 on both sides. And B equals 12. Now, all I have to do is see what is the current. I just found the boat's rate. The current, we know that the boat plus the current equals 21. So I say 12 plus what equals 21, and C is equal to 11. So I found the boat speed of 12 and the current speed of 11. Pause the video if you need to, write this down, and then we'll move on. Another example. Mr. Duffy went to Staples to buy school supplies. He bought 4 pens and 5 pencils, which cost me $6.71. Mr. Schwinn also went to Staples later that week and bought 5 pens and 3 pencils, costing $7.12. Let X be the price of a pen and Y be the price of a pencil. So I'm going to write an equation that relates the number of pens and pencils Duffy bought to the amount he paid for them. So what I'm going to do is say that X is the price of a pen, and I bought 4 pens. So that would be 4 times X, and then I'm adding the price of my pencils. I bought 5 pencils for a price of Y each, and I know that totaled $6.71. Write an equation that relates the number of pens and pencils. I should have said Schwinn. It should be Schwinn if you're following along. Bought to the amount he paid for them. So Schwinn bought 5 pens at a price of X plus 3 pencils at a price of Y, costing him $7.12 total. Now we need to solve the system to find the price of the pen and the pencil. Well, that's not too bad. If I have 4X plus 5Y equals 671, and 5X plus 3Y equals 712, I can solve that. What I need to do is find a common multiple. Probably the easiest way to do it is multiply this by 5, every single term, and this by 3. What happens is that when I take 3 and multiply it by 4x, I get 12x. 3 times 5y is 15y. And 3 times 671, let me see what that equals. And that is $20.13. Now the bottom one, I'm actually going to multiply by -5, and you're going to see why. Because when I take -5 times 5x, I get -25x. -5 times 3y, I will get -15y, and that will be what cancels out. And then 5 negative 5 times 7.12. That equals negative 35.6. Good. Now I can solve this. Add them straight down. 12x minus 25x is negative 15x. 15 minus 15 cancels, so I don't have any y's anymore. And then 20.13 minus 35.6 is negative 15.6. Divide by 13, negative 13 on both sides. And I get the price of x, and that was for the pens, being $1.20. Okay, good. Now what I have to do is plug this in for one of the original equations. I'm going to plug it in for my equation, which was 4x plus 5y equals 671. And so that's going to be 4 times 120, or I just put 1.2, plus 5y equals 671. 4 times 1.2 is 4.8 plus 5y, 671. Subtract 4.8 from both sides. Still have 5y over here. 6.71 minus 4.8 is 1.91, excuse me. Divide by 5 on both sides. And you get 0.38. So 38 cents for the pencils and $1.20 for the pens. Going on to number 5. I worked the ticket booth at the last home game for the basketball games. A student ticket costs $1 and an adult ticket costs $3. 292 total tickets were sold, amounting to $470 in ticket sales. S is the number of student tickets, and A is the amount of adult tickets. So, what I know is that 292 total tickets were sold. So students plus the adult tickets is equal to 292. And then I also know that they amounted to $470 in sales. So a student ticket was $1, so I'm going to say 1 times the amount of student tickets plus the adults cost $3. So 3 times the number of adults tickets is equal to 470. Now this is a system we can solve. All we have to do is make it so that the S, one of these S's is negative, and we'll go from there. Let's make it so the top S is negative by applying negative 1 to each of those terms. And all of this right here turns into negative S minus A equals negative 292. And we will solve these two systems, or this system of two equations. So 1s minus s cancels, no s's anymore. 3a minus a is 2a. And then 470 minus 292 is equal to 178. Divide by 2 on both sides, and you get A, the amount of adult tickets, being 89. All you have to do now, plug this back into one of the original equations. Let's use the first one. S plus A equals 292. So the unknown student amount plus 89 equals 292. Subtract 89 from both sides, and you get the amount of student tickets being 203 tickets. Moving on, number 6, I think this is going to be the last one I'm doing with you, is kind of tough, because what I'm saying is that I ran a 10K. or you can call it a 10,000 meter race. My friend Dan was put in a heat that was before me, heat B, and I was put 2 heats behind in heat D. Dan had a 2-minute head start, so they started each heat 1 minute in front of the other. So heat C was 1 minute ahead of me, and heat B, which Dan was in, was 2 minutes. Now, we know the rate that he was running, which is 250 meters per minute, and I was running 310 meters per minute. When I started the race, how far had Dan ran? He had a 2-minute head start, so you take the 2 minutes, multiply by his rate, or you can think of it this way: distance equals rate times time, right? His time was 2 minutes, and his rate was 250 meters per minute. So the distance, 250 times 2, it was 500 meters in front of me. Now, using y for the distance and x for the time in minutes, write an equation relating the amount of time spent running after I had started running to his total distance. So what we're saying is that Dan started, so that was part A, Dan started 500 meters with a 500 meter head start. So I'm going to say that his distance, y, is equal to his rate, 250 times x, x being the time, plus the 500 meter head start. I'm going to do the same for me. So C, part C, I didn't start with a head start, so I don't have a y-intercept. All I know is I'm starting from the beginning, and I'm running 310 meters per minute. So I take 310, multiply by my time. Now I need to solve the system of equations. Well, this is going to be substitution because they're both equal to y, so you set them equal to each other. I'm going to say 250x plus 500 is equal to 310x. Get the x's on both sides, so I'm going to subtract 250 from both, and I get 500 is equal to 60x. Divide by 60. And I get x, a time of being 8 minutes, 8 1/3, or 8.33 minutes. So a third of a minute would be 20 seconds. So that would be 8 minutes and 20 seconds. After 8 minutes and 20 seconds of running, me running, I will catch up to him. But he had already had a 2-minute head start, so his time would have been 10 minutes and 20 seconds. That is the last one I'm going to do with you, leaving number 7 for you guys to do on your own.